looking at, I think this is Module 1. This is Module 1 Vectors, Homework B, Vector Algebra, and Vector Products, and this is the last question in the homework sequence, and this is the Velocity tab. So we have to find v of t. So the given position vector as a function of time is given to be, let's write this in blue, is going to be x of t is equal to r times cosine theta of t, and then r times sine theta of t. Let me write that better. Still not even better. I apologize for my handwriting. So r is going to be constant, and theta of t, let's go ahead and write this out. Theta of t is equal to omega times t, and we know that omega is going to be our angular velocity. So we know that this is going to be our omega is going to be our angular velocity. If we multiply that by the time, then we get theta of t. So let's go ahead and substitute theta of t into the position vector. So that'll give us x of t is equal to r times cosine omega times t, and then r times sine omega times t. And then now the second step is to differentiate the position vector to find the velocity. To find the velocity vector v of t, we're going to have to take the time derivative of each component of the position vector x of t. So let's go ahead and write down our components. So our first component is going to be x of t is equal to r cosine omega times t. And so let's go ahead and differentiate with respect to time. So d over dt of r cosine omega times t. And if we take the derivative of that, that's going to be r times d over dt cosine omega times t. And then we use the chain rule. The derivative of cosine omega times t is going to be minus omega times sine of omega t. So it's going to be d over dt r cosine omega times t is equal to minus r times omega sine omega times t. So right here I was just rewriting. I was just moving things down if that wasn't clear. And then we're solving this right here. That's what we just did. I realized I wasn't making my English very clear. So let's go ahead and look at the second component, where we have y of t is equal to r sine omega times t. I'm going to move my tablet real quickly. So let's go ahead and differentiate this with respect to t. So d over dt, and we are doing r sine omega times t. And that's going to give us r times the derivative of sine omega times t. So let's go ahead and use the chain rule again. So this derivative of sine omega times t is going to be omega times cosine omega times t. So I'm going to go ahead and rewrite this, d over dt r sine omega times t. And that's going to be r times omega cosine omega times t. So let's go ahead and put together the velocity vector. So now that we have both of the derivatives of both components, that's going to be right here, and then right here, we can put it all together. So that means our final answer is going to be v of t is equal to minus r times omega sine omega times t, and then r times omega cosine omega times t. And then there is going to be our final answer. And to find the acceleration, again, it's as simple as taking the derivative again.